Hey everyone, today we're gonna be doing a lead code question which is to find number of students which are unable to eat their lunch. So they are saying like in a school cafeteria they offer two type of sandwiches which is circular and the square in the shape, and they are donated by a number 0 and 1. So they are saying circular sandwich are donated by number 0. Similarly the square sandwiches are donated by a number 1. They are saying all the students are placed, or you can say are standing in a queue one after the another, and each student have their own preferences if they wanted to eat a square sandwiches or the circular sandwiches. Now they are saying the number of sandwiches are equal to the number of students in the cafeteria, and in the cafeteria the sandwiches are placed in a stack format, like they are placed one over the another. So you can see it is something like a plate format, like you can take from the top and you can place to the you can whatever you can say, like whatever placed at the last will be taken first. Okay, so they are saying now each student, if you say here, if the student at the front of the queue, like in the queue, they will be like coming first and first out, and the stack will be like last and first out. So they are saying the student in the front of the queue have their own preferences. They will see if the top of the stack, you can say the sandwich at the top of the stack is equals to their preferences. So they will take it and leave the queue. Otherwise, they will leave that sandwich and go and will stand at the last of the queue. Okay, so it will be like rotating in a circular manner. Similarly, they are saying this will get continued until every student get their choice of sandwich or somebody will be left as uneaten. So we need to find how many students will be left as a like they are not able to eat their lunch due to the sandwich are not preferred with their criteria. They are saying they are given two type of integer array, student and the sandwiches, where a student array having the preferences of the student with 0 and 1, which denotes circular or the square sandwich. Similarly, a stack, you can say sandwiches is array is a type of stack which will be saying, okay, I have this particular sandwich, whether it is 0 or 1. We need to find number of students which are unable to eat their lunch. And if you see, this is our example, we'll look at now, but let's see what is the constant given. So they are saying a student length or the sandwiches length of the array can go from minimum one character to, you can say minimum one sandwich or the element to maximum 100 elements. Similarly, they are saying the size of the sandwiches is equals to the number of students in the cafeteria. Each, you can say each element in the sandwich or the student area array, they donate like type of a sandwich, whether it is a 0 or 1. 0 1 means whether it is a circular or the square sandwiches. Similarly, student array donates the preferences of the student, whether they want a circular or the square pizza, sorry, sandwiches. So let's see how to do this question with the given examples. So I'll write the example. So the first example they have given, like there's some student array which is given 1 1 0 0. 0 means circular and 1 means square. Sandwiches. Sandwiches. Okay, so these are the type of sandwiches they offer. Now they are saying there is one student array and there is one sandwich array. Okay, so I have some sandwiches array and some student array. They are given the type of element, or you can say type of the sandwich in the stack or queue. So they are saying this queue, you can say this students are placed one after the another in the form of queue. Suppose if this is the first student, they will either take or will go to the last position. If the preferences of this student met with the sandwich they want, they will take this and leave the sandwich. You can say leave the queue. If it is not as per their like you can say expectation, they will like come out from the queue and stand at the last. You can say, yeah, there's a number of the, you can say a number of people standing in a queue with their positions. You can say number, if like person one having one as their position index. Similarly, we have person two, person three. Every person either takes a sandwich and leave the queue, if they are not taking the sandwich, they need to come out from the queue and stand at the last. So they are saying the student will follow some queue data structure, like every student standing in the front either takes or go at the last. Similarly, they are saying our sandwiches are in the stack order. So if I say, okay, stack is something like this, and our sandwiches are like placed from start to end. You can say this is our top of the stack, then we have 0, then we have 1, then we have 0. So this is the start. You can say this is the top of the stack, this is the top of the stack, this is the top of the stack. So both element, this is the front, this is the top. This is the front of a queue, this is the top of the stack. What I can do, what they are saying, like person from student 1, you can say this is a student having a preferences 1. They are saying if this preferences met with the top of the stack, they will take this one and leave the queue. So if I say this is my queue, okay, this is my queue, I have 1, 1, 0, 0. So my preferences is 1 and my stack is 0. This is not my preferred, so I will stand at last. Okay, I have not taken this one. Now, if I say, okay, now my second index, you can say second student will come and they will say, okay, I also need one type of sandwich. They are saying I have a 0 type of sandwich at the top of the stack. They will say I don't want. They will leave the queue and stand at the last. Now, person 3, or you can say something we have, like you can say here we have index 0, 1, 2, 3, and 4. Or you can say student 1, student 2, student 3, and student 4 and student 5. So we have 5 student. Student 1 and 2 told I need a type of sandwich which is 1, but top of the stack is 0. Means it is a circular sandwich they are given and they want a square sandwich. Now, if I say I cannot give this one, I cannot give this one. Just go and stand at the last. So student 1 came here, student 2 came here. They just remove, they just came out from the line, or you can say a queue, and stand at the last. Now I have my student 3 at index 2. They say, okay, I want this sandwich. I have my preference as a 0. Top of the stack is also 0. So what I can say, okay, take this sandwich and go out from the queue. So this also will get removed, this also will get removed. I have removed these two from the stack and the queue. Now I have student 4. Okay, they say I need 0 type of sandwich, but my now stack is having type 1 sandwich in the top of the stack. Okay, so I just need to remove this and I just need to append over here, like just I'll say, okay, come out from the queue and stand at the last. Okay, now my, you can say I have this 0 came out from here and extended over here. So student 6, student 4 came here. Now again, once this over, I have my circular pattern repeating again, like student 1 will come now, student 2 later, student 4 later. So what I'll say, okay, now student 1 get chance again to choose a sandwich. Okay, I'll say student 1, take your sandwich. I have taken my sandwich, which is equals to the top of the stack, and just go out from the queue. Now I have removed this one, this one. I now left with, you can say, what I have. Uh, okay, so initially I I was having only 4 students. Okay, fine. So initially this was my students, student 1, 2, 3, and 4. Now I have removed my student 1 and student 3 because their preferences match with this stack. Now my next is student 2, which is having 1 as a preferences, but top of the stack is now 0. I'll say, okay, remove from the queue, go and stand at the last. Okay, just go and stand at the last where this is coming. Now my, you can say student 4 got a chance to pick this sandwich again. So it will say, okay, this is my choice. I'll just pick up the sandwich, get removed from here, and the student will go out from the queue. Now I left with one student which is required one type of sandwich. I'll say, okay, I have taken this one, remove from the queue. So what you see, like I'm just picking a student, checking whether it is equal to the top of the stack. If it is equal, I'll just remove at the, either I'll just place it to the last of the queue. So you can see I'm removing something from front of my queue the student is getting removed from front of the queue and placing at the last of the queue if it is not valid. And similarly, I'm just removing from top of the stack for the sandwiches. So this is our students. Okay, I'll say this is my students. This is my students. Okay, students, and this is are my sandwiches. So what I just need to do, I just need to see whether this is matching with the top of the stack. So if I say very brute force approach, what I can say, okay, just iterate over this one, this student. If I write this again, I have, you can say, I have a stack, or you can say student. I have student st having 1, 1, 0, and 0. Okay, I have sandwiches as 0, 1, 0, 1. Okay, this is my student and sandwich. What I need to do, I just need to check whether this is first index, whether this is equals to this. If it is fine, I just need to remove both from their respective array. So if these are the equal, if this both are equal, I just need to remove both. Otherwise, I need to place this student at the last of the index. So what I need to do, I'll just keep on checking both front, you can say top of the stack and front of the queue. If it is equal, if both are equal, I'll say okay. There's one more catch. You need to repeat the element. If it is getting removed, it will stand from here to here. Okay, similarly, he will stand from here to here. This will keep on going. So we need to find how long till it can go. Okay, so if it is satisfying my condition somewhere, they will pick this. Otherwise, if I say for the next example, okay, there is some student, or you can say I have some student array which is 1, 1, or 1, 0, 0, and 1. Okay, and we have some sandwiches which is 1, 0, 0, and 1, or you can say 0, 1. Okay, 0, 0, and 1, 1. So what they are saying, okay, just to make a queue, I'll say okay, I made the queue. I have placed my you can say this sandwiches. Sandwiches are 1, 0, 0, 0, 1, and 1. And I have my students formed in a queue. Okay, I'll say my initial formation in a queue is 1, 1, 1, 0, 0, 0, and 1. They are saying if you are matching, just go out from the queue. I'll say okay, these two will get matched, they will not appear again. Otherwise, if you say now this is not getting matched with this one, this is also not getting matched this one, I'll say okay, just remove an element, compare whether it is equals to this. No, I'll just place over the last of the queue. Similarly, I remove this one, I'll just place to the last of the queue. So what I'm doing, I'm just checking the front of the queue. For the first case, this was the front. For the second case, this was the front. For the third case, this was the front. Now my front is 0. I'll say, okay, this is top of the stack. Just both can get removed from here. So I'll say remove, remove. These two I removed initially. Now again, I have this 0. I'll remove this one. Now if you see, I'll keep on moving. If I say I just remove this, I placed over here. Remove this, I placed over here. Remove this, I'll place over here. I remove this, I'll place over here, because now my top of the stack is 0. If I remove any number of 1 from here, it will not take any 0 type of sandwich. You can say this is a square type of sandwich they want as a preferences. They want square sandwiches. My sandwiches are of circle type. So if I have my top of the stack as a circle, any number of square cannot pick this one. So this will keep on repeating. This will go and place at the last. It will go and place in the last. This will go and place in the last. So both, like every time they will go and just keep on appending at the last. This keep on following. So we need to like maintain some patterns over here, like how far it can go. So what I can do, I can keep track of you can say something related to size. So if I say okay, let me tell you, like we will be like repeating something one after the another. Something like while we will repeating till you can say I'll repeat some indexes. I'll say okay, there will be some indexes. I'll say this is my index. It is started from 0. I have some size. It will be length of array, any array. Okay. What I'll do, I'll just iterate till my index value is less than size. So what I need to do, I just need to see if my all elements get executed in one pass. So this while loop will get terminated. If I just pop and place any of the element, I just need to shrink my array size and I need to start my index from 0th position. So if there is some changes, this condition will get modified. Otherwise, this will get on executing like till this index is less than size. And once it's satisfied, it will come out from the loop. So what I can say, okay, every time just check. Okay, what I'll do, I'll take this one, this example. I'll write at sim. Okay, this is something. Okay, I have this one. I can duplicate. I just need to modify. Okay, this is my array. What I'll say, okay, start from 0, 0 position for both. Just keep on comparison. What if both the element, if I say student and if student index 0, you can say top of this front of the queue is equals to, you can say sandwich, top of the sandwich, you can say stack. So if both are equal, I just need to pop from both. Okay, so if these are equal, I just need to remove both of them. So I'll just remove 0th index from both because I'm just considering my array. Okay, I'm not creating any queue or any stack. I'm just considering this as a like some data structure I can run on. So I can remove this if it is equal. Now my index again becomes 0, 0. I just need to say okay, index again will start from 0. Size now will get decreased by one element. You can say size will minus equals to 1. You can say size minus minus. Okay, size just remove from one index. Just like the window size, you can say stack size shrink. If it is not a case, what it will do, else case, it will say, okay, my index position will get incremented every time. If you say, if it is not equal, in this case, if this is not equal, I just need to check for the next index. So if I follow the pattern, if I say I'm standing over here, my new position is this one. This is my new index. You can say 0. Every time when it get deleted, it will start from 0, but I have this as my window. Now my size started from 0. I have 3 size. It will keep on checking, keep on checking, keep on checking, and it will get excluded. You can say it will come out from the loop. You can say index will less than 3. Once it is completed, it will come out of the loop because it is not getting compared anywhere. Like 0 is not equals to 1 in any of these cases. So I can say index will get plus plus. So this loop will get terminated if I surpasses the equal number of, you can say, repeated character. So I can say okay, index plus plus, and what I can say, okay, just append this. You can say student dot append. I just need to append what? I just remove the student from the first index. I'll say okay, student from 0th index, just pop and go and set to the last position. So this is my like very brute force code. You can say I'm just iterating, I'm just storing. You can say I'm just storing this to my stack. I'm just keep on pushing and appending. I'm just appending. I'm just popping. So this is to say the time complexity is like, you can say order of n for both of the iteration. Like this loop can go till order of n, another order of n. Similarly for storing also I can say I'm using something order of n as a time space complexity. I need to optimize something. So if you see, if I need to optimize, what I can do instead of storing something, I can make a use of a count. So what I can say, okay, I'll start I'll say okay, use this one. I'll use this example. Okay, I'll use this example. I'll say just keep on, just keep pushing your element, just keep a count of your element. I'll say if this is your case, just make a count like how many circles sandwich are there. So circle sandwich, you can say I have number of 0 as my circle sandwich. Like the ask from the student, I have two circles asked. If I say how many square sandwich ask are there from student, I'll say okay, 1, 2, 3, and 4. Four sandwiches are asked as a, you can say, square type. Now I have this student asks, you can say preferences, two type of circular sandwich and four type of square sandwiches asked from the student. Okay, I'll store this count which is asked from the student. Now I'll iterate over this sandwiches. If you see, my students are placing one after the another. If they are getting satisfied, they will go out. If it is not, they will place next, or you can say last in the queue. But they will keep on rotating. So if I say, if I have something, it will get you can say concluded. If it is not, they will just see it is not there in the queue. So if I say I now iterate from the sandwiches and I'll just keep on serving. Number of student want this one will take. So if I say okay, number of ones, there are four, I'll say okay, if it is sandwich which is one, I'll just decrement my square sandwiches. If it is equals to square sandwich, I'll decrement this one. This is equals to this, I'll decrement this one. Now my circular sandwich are came to 0. I have only two asks from the student. Now I have no ask of a circular sandwich from the student. But if you see, my top of the stack has 0, or you can say circular sandwiches, which is not required from any of these student. I cannot remove from here because it's already 0. And I have left 3 students because until unless we remove this 0, I cannot give 1 to any of them. So if you say I left with a 3 student, which is waiting for this one type of a sandwich, you can say square sandwiches, but this 0 type, or you can say circular sandwich, is placed on the top of this stack, you can say. So I have left my 3 students which are need to be, you can say, which will be left as a uneaten. So I'll code up with the, you can say, the optimized code. Okay, let me code up the optimized one. So what I'll do, I'll simply write the code for the optimized one, and the, you can say, the brute force I already wrote in the notes. So you can watch, rewind the video. So what I can say, I'll use some store, I'll just store the count of a circle sandwich, and the, you can say, square sandwich. Okay, so I have two type of sandwich. Both are now at 0. The student asks, you can say preferences are at 0. I'll say, okay, choices of a student, choices in student, students. I just need to see which student want which sandwich. So if this choice is, if I say choice is equals to 0, this means the circular sandwich is asked. Okay, circular sandwich get plus equals to 1. If it is not, else means there are two type of sandwich. Else means their choice is 1. 1 means square sandwiches get incremented. So here I will just store how many type of sandwiches are required from the student, like which type of a sandwich. So I have my square and circular type of sandwiches as, or you can say preferences of the student. Now I'll iterate from the sandwich array. I'll say which of the sandwiches are at the top of the stack till now. You can say at present. I'll say okay, you can say sandwich at the top of the sandwich stack. I'll say okay, the sandwich stack, tell me which is at the top of you. So it will come, it will check if sandwich, this sandwich is equals to what? 0. 0 means circular. And if we say, okay, if I have asked for the sandwich 0, and if I have my circular choice, okay, my circle choice is equals to 0. It means I don't have any circular sandwich left. So what I can say, I'll say, okay, return number of sandwich which is square. You can say number of sandwich asked from the square. You can say student preferred a square sandwich. You can return like they will be left uneaten, because we are saying our top of the stack is showing circular sandwich, but we have not like the student no longer want a circular sandwich. It means number of square sandwich, you can say the preferences of the square sandwich which is left behind will be the number of students which are left uneaten at last. Okay. Similarly, if I say this can be same case, if I say I have a number of sandwich which is equals to the square and my square sandwiches now are 0, means I don't have any ask for the square sandwiches. So this time I can return number of circular sandwich which are the student which are uneaten for now. Similarly, if I say okay this will be LF, now again one condition, if that is not a case and we have a student with their choices and number of preferences are greater than 0. So now if sandwich is equals to 1, you can say is equals to 0 or 1 anything, it means you need a square type of sandwich or the circular side type of sandwich. If one of them is getting asked, I just need to decrement its count. If it is 0, I just need to decrement ask of a circular sandwich. If it is equals to 1, so I'll say else case, if sandwich is equals to 1 or the square sandwich is asked, I just need to decrement its count because it will be given to some person and it will get deleted. At last, if some everything is satisfied, if all the sandwiches are given to all the student, at last the size you can say there will no student left uneaten. So I'll say okay return 0 in this case. I'll compile this code. Let's see whether it is working fine or not. So this is like accepted. I just need to submit. So if you see, we have done this code and it's pretty much optimized. We have done in the linear time complexity. One is for counting the student preferences and another like just we are giving the, you can say serving the sandwiches as per the preferences of the student. So we have just done this in a linear time and in a constant space. So this is what our question asked, and that's all for today's. Thanks for watching.